Okay, Math 9, so here we go. We are doing a short video, so just a quick look at multiplying and dividing a common base. So remember, this ties into our section 2.2. We're just going to look at a few examples here in context so you can see them. Real quick, real easy. So here we go. The first question you need to ask yourself is, do you have a common base? And remember, the base is the number, the bigger number, right? The small number is the power or the exponent. So when we ask, do you have a common base, you need to look at that. It's like, well, do I? Yes, it's a 3, and a 3. So if you have a common base, the questions are very, very straightforward because the rule states that if you have a common base and you add it together, and you multiply it together, so if you have 3 to the 2 times 3 to the 3, what did we do to those exponents? We add them together. And why do we do that? Because 3 to the 2 means 3 times 3, 3 to the 3 means 3 times 3 times 3, and we are multiplying them together. So we just have a continuation. We just add them all up, we get 3 to the power of 5. So you can see here, yes, we have a common base. So it's as simple as going, okay, 4 plus 2 plus 3. We have 3 to the power of 9. Do I care what 3 to the power of 9 is? No, it's a pretty big number. So the whole goal here is just, do we understand our exponent laws? Now look at a number in brackets. If they're all in brackets, so in this case, -2 in brackets, -2 in brackets, -2 in brackets, that matters. We end up with -2 in brackets as our base, and we add the exponents, 3 plus 2 plus 6. So we get -2 in brackets to the power of 11. Now this answer would be suitable, but when you're done, you could now ask yourself that forever positive or forever negative question. Since this one is forever negative, it would be synonymous to write this statement. So both of these things are accurate, but be really careful there because if it was an even exponent, they would definitely not be accurate. So you can only do that if you are certain, okay? But if you have a common base in brackets, in each scenario, keep your base in brackets. Just makes life a lot easier because in a second here, we'll see what happens if we don't. So division is the same thing if you have a common base, except in this case, consider what you have. You have 3 times 3 times 3 times 3, and you have 3 times 3. So we have factors on the top and bottom. And if you remember section 1, canceling out common factors, that's what we're doing here. Do I have a 3 on the top? Yes, cancel, cancel. What are you left with? You're left with 2 3s. So you're left with 3 to the power of 2. Well, so what does that mean we did? If we multiply a common base, well, when we divide, we subtract the exponents. Multiplication we added, division we subtract. Opposite of multiplication is division, opposite of addition is subtraction. So for this next one, again, we have a common base. It's -2 in brackets, 3 minus 2. So -2 in brackets to the power of 1, or you can just say -2. You can just say -2 in brackets because it's assumed to the power 1. But again, that's also the same as just saying -2. So be aware of the different forms, but make sure that they are indeed accurate. Okay, so what happens if we don't have a common base? So here we are, multiplication. Remember, we don't have a common base. It's close, but it's not exactly the same because here we have a negative in brackets, here we have a negative no brackets, and here we have no negative. So we know our final answer is going to be a 3. We just don't know if it's going to be positive or negative. So we have to ask ourselves forever positive or forever negative. And for the first one, it's in brackets and it's to an even power, so that means it's forever positive. For the second one, there are no brackets and it's negative, so that means it's always going to be negative. And then for the last one, well, there isn't even a negative sign. So remember that if something's forever positive, we can write it as its positive counterpart. If something's forever negative, it's helpful to demonstrate that there's a -1 sitting there. And then the last one, nothing changes. So since we're multiplying everything together, just to show in vivid detail, the -1 can move to the front, and now you have 3 to the 4 times 3 to the 2 times 3 to the 3. And the reason why that -1 can move to the front is because order doesn't matter in multiplication, and it just shows you that we have a common base here now of 3's. So then we would add the exponents up. 4 plus 2 is 8, plus 3 is 11, so we have 3 to the 11, but this -1 here means my final answer is going to be negative. So on the next one, here, again, we have a negative exponent, but that has zero effect on the positive negativeness of our base. All that matters of our base is if there's brackets. And here there's no brackets, okay? So that means this is forever negative, regardless of the exponent. This next one here is forever positive, because I have an even exponent. And then this is forever positive because I have no negative at all. So again, I have a negative 1 here, and then 2 to the negative 3 times 2 to the 2 now, times 2 is 6. And adding negative exponents is the same process. We're just adding a negative number. So negative 3 plus 2 plus 6, we end up with negative 1 times 2 to the power of 5, which means we have negative 2 to the 5. So the negatives throw a bit of a monkey wrench in there, but it's nothing overly challenging once we do our forever positive, forever negative. And just a note on negative exponents. If you don't have brackets, it doesn't matter if the exponent were positive. It wouldn't matter what the exponent is, odd or even, right? It's always going to be negative, forever negative, forever negative. If you had it in brackets, then it would indeed make a difference, right? If it's even versus if it's odd. Now, those are positive exponents, but here we have a forever positive, and here we have a forever negative. Now, if you have a negative exponent and you have it in brackets, it still doesn't matter that the exponent's negative. What matters is still, is it odd or even? And yes, negative 2 is negative, but it's still an even negative number. So that is still a forever positive statement. You would end up with 2 to the power of negative 2. And this would be a forever negative statement. You would end up with negative 2 to the power of negative 3. So it's the odd or evenness that matters, not the negative of the exponents. We will look at negative exponents as a bonus video, but you're going to see them in grade 10 and definitely into grade 11 and grade 12 and so on. So I wanted to introduce them to you here, not as things we operate with as far as negative to positive goes, but as just adding and subtracting positive and negative numbers. So why not? So let's look at a division example. So again, watch your negative exponents here for sure, because for division we subtract, right? So now if we look here, we have forever positive, and if we look here, we have forever positive. So we know our answer is going to be positive. We have 3 to the power of 4 over 3 to the power of negative 2. And here's where you got to be careful because you're subtracting exponents. 4 minus negative 2 means 4 plus 2, which means 6. So we end up with 3 to the power of 6. And then on the last one here, no brackets, so forever negative. Brackets, even number, so forever positive, which means we have a negative 1 times 2 to the 13 over just a positive 2 to the 8, because negative 2 in brackets, 2 and 8, is the same as saying 2 to the 8. And now we know our answer is going to be negative because we have this negative 1 here, and then 2 to the 13 minus 8 gives me 2 to the power of 5. So dealing with the negatives first kind of isolates them from the question, and then you get back to your common base with respect to the number, and you can go from there. So keep it up here. Remember, this connects to section 2.2. The negatives do get a little bit more complicated, but if you just consider a common base and your exponent laws, lock that down for sure. Great work.